Okay, so welcome to lesson 3.2. We're going to be solving equations with the distributive property today. So by the end of the lesson, that's how we should be able to solve our equations. So first thing that we want to remember here, let me get my pen ready. So when we're solving an expression, right, not an equation, so when we're solving an expression, we want to use the acronym BEDMAS to remember our order of operations, right? Some of you might use P instead of B, right, for parentheses, but I'm just sticking with brackets. Now, we learned in our last lesson that when we're isolating for a variable in an equation, we're going to use the acronym SAM-DEB, right? So the opposite of our BEDMAS to help us remember the order of operations. So we're gonna practice a few solving equations first before we get into our lesson. So just to refresh our memory from last time. So in this case, we look at it, what's happening to x? Well, 8 is being added to it, so we want to do the opposite. So we want to subtract 8. So remember, you're always going to subtract from the other side. So x is going to be negative 12. In this next one, what's happening to b? Well, it's being divided by 4 and 7 is being subtracted. So again, using our order of operations for equations, we want to do the add subtract first. So I'm going to leave that b over 4 alone. Now I'm going to add 7 to the other side. So we've got negative 2. And then to get rid of this dividing, we want to multiply. So those go away, and b equals negative 8. In part C here, we're multiplying by negative 3 and we're adding 20. So again, we want to get rid of that adding first. So we're going to subtract 20. We've got negative 15. And then to get rid of our multiplying, we're going to divide by that negative 3. And we get 5. Okay, and then this last one here, well, we're adding 8, we're dividing by 4, and we're multiplying by negative 3. So we've got a lot to do here. So again, we want to get rid of this adding first. So I'm going to leave that fraction alone. And then this 18 here, right, we're going to bring it over here, and then we're going to subtract now. So we're left with 6. Then we want to get rid of this dividing here, so we're going to multiply by 4 to get rid of that. And then lastly, we want to get rid of this multiplying, so we're going to divide, and we've got negative 8. Okay? All right, so we're also going to practice some word problems today before we get into this distributive property. Okay? So for each word problem, we have to write an equation that models the situation, and then we're going to try and solve it. Remember, whenever we have these word problems and we're using variables, we always want to have a let statement to explain what that variable means. So in question A, we have Colin ordered 3 pizzas. He went to the store to pick up the pizzas. It came to $27. How much did it cost for each pizza? So we're going to say I'm just going to use x. Let x represent the cost of pizza in dollars, right? How much did it cost for each pizza? That's where we're getting what the x is. So it says that he ordered 3 pizzas. So we have 3 times whatever that cost of the pizza is. And when he went to the store, it cost $27. So 3 times whatever the pizza cost equals 27. So in this case, right, when we solve this, we just need to divide by 3 to get rid of that 3 there. So 27 divided by 3 is 9. So we could say, therefore, price of a pizza is $9. I wish. Okay. So if Colin ordered 3 pizzas but paid a $1.50 charge for delivery, now how much was each pizza? And we're going to assume the total is still $27. So we're still going to let x represent the cost of pizza in dollars, right? That hasn't changed. But now it's a little bit different of an equation. So we still ordered the 3 pizzas, but now on top of that, we had to pay this $1.50 delivery. And they told us we're gonna assume this still cost us $27 in total, okay? So now we need to undo this, adding the $1.50. So we're gonna do the 27, now we have to subtract $1.50. So we get $25.50 here. And then to undo the multiplying, we need to divide, right? Those go away, and we get $8.50. So in this case, therefore, a pizza will cost $8.50. So even cheaper. I like this pizza place. Okay, so let's try part C here. We've got a banquet hall charged $200 for the rental of a hall. Right, so if you rent it, it costs $200. Plus, they charge $24 for each meal that they served. So every person that eats, they have to pay $24. So the total bill for the banquet was $3,800. Now we want to know how many people attended the banquet. Okay, so it said that we had to pay $24 for each meal. Okay, and we assume one person eats one meal. So in our let statement, we're going to say let X represent the number of people. Because number of people, right, one person eats one meal. So if we're writing our equation here, we know the banquet hall charged $200 for the rental. So we had this $200 cost. That's just for 0 people to show up. It costs you $200. But then they had $24, so you have to add $24 for every meal that's eaten. So that's our X, right? We have to figure out how many people are eating. And we know that the total cost was $3,800. So now we have to solve our equation. So we want to undo this adding the 200. So we're going to subtract it from this other side here. So we've got 3,600. And then we want to get rid of our multiplying by dividing. So X is 150. So we could say, therefore, there are 150 people at the banquet. Okay. All right. And then the last word problem here. These ones, again, 3 more than twice a number is 15. Find the number. So let X represent the number. They're not really more specific than that. Okay, so now we have to use our math language to help figure this out. So we've got 3 more. So 3 and then more. So that means plus. Then twice a number. So 2 times that number means equals. And then 15. Okay. So let's solve our equation. So now we want to get rid of that plus 3. So we're going to subtract 3. And we've got 12. And now we want to get rid of our multiplying by dividing. X equals 6. So therefore, the number is 6. And for any of these, you could always go back and check your work by using like the left side, right side example that we did before. Okay, so now let's move on to this actual solving with the distributive property. So in this case, we have brackets in our equation. So when we have brackets, we're going to need to expand and simplify before we can actually solve here. So we're going to write some success criteria first, and then we're going to actually try and solve these. Okay, so we want to distribute into the brackets. Then we want to collect like terms. And then lastly, we want to isolate for the variable. And we're going to use our SAM-DEB order. Whoops, B. Okay, so we're going to try this example 3. I don't really have room to write up here, but I do have a lot of room at the bottom of the page here. So I'm going to call this example 3, and I'm just going to use this space down here because I have a lot of room. Okay, so for part A here, we've got 3k plus 8 equals 21. So if we follow our success criteria, we want to distribute into our brackets first. So we've got 3k plus 24. And we should remember from our last unit, right, distributing means multiply. So then next we want to follow our order of operations. So we want to undo this adding by subtracting. So we've got 3k equals 21 minus 24. And 21 minus 24 is negative 3. And then we want to undo this multiplying, so we're going to divide. So k equals negative 1. All right, try B. So we've got 10 minus 2 brackets w minus 4 equals 12. Okay, so be careful as much as you're going to want to. You cannot do 10 minus 2 here. We have to distribute that 2 first. So we're going to leave our 10 minus, and now we have to do that negative 2 times w is negative 2w, and then negative 2 times negative 4 is positive 8. Okay, next we want to collect our like terms. Okay, so the only w's that we have, we're going to keep on the left side, so we only have this 2w. On our right side of our equation, we want to put all these constants, right? So we're going to undo the operations. So we have this positive 10, so we're going to minus 10, and we have a positive 8, so we're going to minus 8. So now we've got this negative 2w, and then we can actually do this part over here. So 12 minus 10 is 2, minus another 8 is negative 6. And then last step here, we need to undo this multiplying by dividing, and we get w equals 3. Alright, let's try C. So we've got 28 equals 9m minus 2 times 2m plus 6. Okay, so we can't do anything on that side. And again, we can't do this 9m minus 2, so let's leave the 9m alone. We're going to distribute the 2. So negative 2 times 2m is a negative 4m. And then negative 2 times 6 is negative 12. Now, we want to collect our like terms. So we have m's here. Let's move in this time, let's move all of our constants over to the right or left-hand side. So we've got 28. We had minus 12, but now we're going to add 12. And then we're just going to leave these m's here. So now let's simplify. So we've got 28 plus 12 is 40, and 9m minus 4m is 5m. Now we need to isolate for our variable. So in this case, in order to do that, we're going to need to divide both sides by 5, and I'm just going to flip this because it looks prettier. So m equals 8. Alright, and then the last one here, hopefully I can fit it in, 2 times 3x plus 5 plus 3 times 2x plus 5 equals 1. Ooh, can fit it. So we're going to have to do some distributing first here. So we've got 2 times 3x is 6x, and 2 times 5 is 10. And then let's distribute again in here, plus 3 times 2 is 6x, and 3 times 5 is 15, and that all equals 1. So now, again, we're going to collect our like terms. So we're going to have x's on one side and constants on the other. So we've got a 6x plus a 6x here. And then on the other side, we have 1. Now undo your operations, so a positive 10 becomes a negative 10, and a positive 15 becomes a negative 15. All right, now let's simplify. So we've got 6x and 6x is 12x. 1 minus 10 minus 15 is negative 24. And now last thing we can do is isolate for that variable. So again, opposite operation for multiplying is dividing. Divide both sides by 12 and we get -2. Okay, so I'm going to go back up for a second to my example 4 here. So in this one, this is kind of like real life question here. So we have a rectangle that has a length of 7x minus 4 and a width of 8 minus 2x. And we know the perimeter is 38 centimeters. So we want to determine the length of each of the sides. So we're going to have to figure out what this x actually means. So I'm just going to move down here. So this is my example 4. So I'm going to draw myself a picture of what they just told me. So I know that my perimeter is 38 centimeters, and they told me that the length was 7x minus 4, and the width was 8 minus 2x. So I know that my formula for perimeter is P equals 2 times the length plus 2 times the width. They told me that my perimeter was 38, and I know my length is 7x minus 4, and my width is 8 minus 2x. So now we're just going to have to treat this like a regular equation. So we're going to distribute first. So 2 times 7 is 14x, and then 2 times -4 is -8, and then distribute here, plus 2 times 8 is 16, and then 2 times -2x is -4x. So now let's collect our like terms. So this time I'm just going to move constants to the left. So I've got 38 already there. This -8, undo it, +8. This +16, going to become negative. And now my x's, I'm just going to leave them alone on the side they were already on. We don't need to change any signs. So 38 plus 8 minus 16 is going to... Okay, so 38 plus 8 is, what do I have here? Oh boy, 46 minus 16, 36, so 30. Uh-oh. Oh no, not again. My pen decides to not work again. Such a pain. Let's try and... This worked last time. There we go. Okay, so what did I just say this was? 30. Yes. And then 14 minus 4 is 10. So then divide both sides by 10, right, to get that x on its own. Isolate for our variable. 30 divided by 10, x equals 3. Okay. So we're not done here because the question didn't ask us to solve for x. It asked us to determine what the length and the width actually were. So now we're going to have to figure out what the length is. So I know that length is 7x minus 4. And I'm going to sub in what I got. So x was 3. So 7 times 3 is 21. Minus 4, we get 17. And now we know it's centimeters because they told us that the perimeter was 38 centimeters. My width, 8 minus 2x, so 8 minus 2 times 3, this is 8 minus 6, which is 2 centimeters. So then therefore, the length is 17 centimeters, and the width is 2 centimeters. Okay. Alright, so we've got a couple more examples here and then we're done. So example number 5 here, the figure below has a perimeter of 77 meters. We want to determine the length of side AB, and we need to show our work. Okay, so if we wanted to find the perimeter of this shape, we would just add up all the sides, right? So let's write that in. So my perimeter equals 77. So I'm just going to say 77 equals, so that's my total perimeter. And now I just have to add up all my sides here. So 4x plus 2 plus 3 times 4x minus 5 plus 5 times 2x plus 3 plus 7 times x minus 9. All right, we got all 4 sides accounted for. All right, now we need to solve for x here. So we've got a lot of distributing to do. So we're going to get through that first. So 4 times x, 4x, 4 times 2 is 8, plus 3 times 4 is 12x, and 3 times negative 5, negative 15. Plus 5 times 2 is 10x, 5 times 3 is 15, plus 7 times x is 7x, and 7 times negative 9 is negative 63. Whew. All right, so now let's collect our like terms. I'm going to just do it on the same side just to make this a little bit simpler. And so we've got, I'm going to collect all my x's together here, and then I'm just going to do all of my constants on the same side, because we can simplify on a side too. So we've got 4 plus 12 plus 10 plus 7 is 33x, and then 8 minus 15 plus 15 minus 63 is negative 55. All right, that's a little easier to look at. No, this is 77, even though it doesn't look like it. Okay, so now let's move or do my opposite operations. So I've got 77. Here I had minus 55. Now I'm going to need to add 55. And then I've still got this 33x. So 75 plus 55 is 132. And then we've got this 33x. So we need to divide both sides by the 33. So x equals 4. And this would be meters, because it said meters up here. But what they actually asked for was the length of this side, right? AB. So, AB length equals, and we know it was represented by this expression, so we're going to sub in to that expression. So 2 times 4 in the brackets is 8 plus 3, and 8, 9, 10, 11. So this is 55, and meters, right? Don't forget our units. So then, therefore, length from A to B is 55 meters. All right. And then the last example here, okay? So in this example, they want to know, is x equal to -1 a solution for the following equation? Okay, so there's 2 ways that we could prove this. Okay, we're going to try both ways, and then it would be up to you to determine which way you want to do it. So method 1 would be a formal check. Okay, this one we do our left side and our right side. So the left side was 3x plus 2x minus 6, okay, and the right side was negative 5x plus 3. Okay, so we're going to just sub in x equals -1. So wherever we see an x, we need to put in a -1. So in this case, 3 times -1 is 3, plus 2, bracket, -1 minus 6 is -7. So then multiplying first, 2 times -7 is -14, and we've got -17 here. All right, so let's try this other side. So -5, x is -1 plus 4, -5, and now we've got -1 plus 4 is 3, and this is -15. Okay, so we did not get the same answer. So we would go ahead and assume that x equals -1 is not a solution. I would double check your work just to make sure you didn't make a mistake, but we definitely didn't. So in this case, our left side doesn't equal our right side, therefore x equals -1 is not a solution. Now the other way we could do this right, is to isolate for x, right? We could actually just solve and figure out what x is. So we're going to try that as well. All right, so again, now we're just going to solve our equation. So distribute first, so 2 times x, 2x, 2 times negative 6 is negative 12, and then over here, negative 5x minus 20. Now let's collect our like terms. So we've got 3x plus 2x, wow, that's a weird 2. 2x. We have a 5x over here, so we have to do the opposite sign. Leave that negative 20, and then let's undo this 12, so plus 12. All right, on this side, we've got 3 plus 2 is 5, plus another 5, we've got 10x. And then here, negative 20 plus 12 is negative 8. And then we want to get rid of that 10. So we've got negative 8 over 10, which can reduce to negative 4/5. So yeah, negative 4/5 does not equal negative 1. So therefore, x equals negative 1 is not a solution. Okay, so it'd be up to you in this type of question, right? You could do the formal check, or you could just isolate for x to try and determine if x equals negative 1 is a solution. Either way would be correct. All right, so that's the end of this lesson. Hopefully you feel comfortable with distributing in an equation. Okay, so try your homework, ask questions.